this computer. All right, so today we're going to cover inequalities. It's very simple, very straightforward. Shouldn't be an issue. Okay. I do have enough batteries to do this, do I? 49%, more than enough. So I want to cover inequalities. I think they're kind of important. And hopefully when we're done, you should be okay. I feel like I'm blocking your view. I sit there. I'll sit over here. I don't block anybody's view. So let me get the mouse. Make everything a little bit easier. Nobody wants to buy a Microsoft Surface? Why is that?
It's overly expensive.
This is chapter 5. All right, so let me go ahead and pick a question here. I don't know. So I'll pick this question right. Wait, no. I'll pick that one. Obviously, it's, oh, come on. I'll just write it over here. So we have x minus 3 is greater than 11. Like, is that hard? What do you do? Yeah, just add the 3. So this is a non-issue. This is a non-issue. Now, where does this become an issue? And you know what? This becomes an issue sort of like when I have something like this. Yes, only if you're careful. Oh, you guys almost crashed. So when you have something like that, I mean, if negative x is greater than 20, what does x have to be?
Negative 20.
So if negative x is greater than 20, then x must be less than negative 20. Is that true? That's super important. If you don't realize that, then you can't do any of the inequality problems. I mean, you can do some of them, but you'll mess up on the ones that have negatives in them. In other words, when we divide by a negative, in this case, -1, it changed the orientation of the inequality symbol. It changes what it means. And you can go ahead and try different answers to see why that is true. So anytime, so let's say I gave you the following. Negative 5x is greater than 20. You would write the following. Actually, let me go ahead and, yeah, I'll do it that way. You know what? Here's what you're supposed to do. You're supposed to divide by 5. Then you have negative x is greater than 4. But when you divide by -1, then you're supposed to change the orientation. Yep. So what I need to remind you of is right here, if you did it like this, all you got to do is solve it, but you have to change the orientation of the inequality symbol. So always, if at any phase in the problem, at any phase in the problem, if you're multiplying or dividing by a negative, it causes a change in the orientation of the inequality symbol. Super important to remember that. And then the rest is history, because, give me a second, because I see that email and, oh my gosh, these people don't stop sending me emails. So, let's flip it.
Wow, I was super confused. I was like,
yeah, you gotta change the orientation of the inequality symbol, because if not, it won't make sense. Like if you start substituting values, you'll notice that it's wrong. Okay. That's the great thing about inequalities, that you can always check to see if it's right or wrong. I mean, you can always do that for everything, actually. You can always check whether you're right or wrong if your arithmetic is good. Yes. Thank you.
What is it that you said dividing or multiplying by negative changes the orientation of the inequality?
Symbol.
The inequality.
Yes. Yes. So let's do a question like from the book and go through it. I don't even have to do it from the book. I can just make them up by myself. Let me just make it up because I don't want to switch back and forth between the book right now. So let's say I gave you the following. Negative 2x minus 2 divided by negative 5 is greater than 4. How would you solve that? Multiply by negative 5, both sides. I know what you meant. So if I do that, what happens to the orientation of my inequality symbol?
Flips.
It flips because I multiply by negative 5. Now I'm going to add 2. So negative 2x is less than negative 18. Then now what do I do?
Divide by negative 2.
Divide by negative 2. And if I do that,
Flip it again.
You flip it again and ta-da! That's the answer. You want to make a graph of that. Here's 9. Open circle. Greater than, that way. And in a nutshell, that's 5A. That's 5A. Make sense?
Yeah.
Questions or concerns? That's the extent of 5A. There's nothing else to it. Do you know how to solve linear equations? Hopefully. Can you remember at any point in time, whether it's at the beginning, in the middle, or in the end, if you're multiplying or dividing both sides by a negative to change your orientation of an equality symbol? That's all you got to remember. Fair enough? Okay, good. So now we go to something less agreeable. It's these guys. Quadratic inequalities. So they have a few methods they're going to go through here. They say use sketch graphs to solve the following inequalities. Then they say use a table based on critical values to solve inequalities. And then they say for 3, use algebraic methods. And then use any method. So let's go through all of it. Let's go through all of it. So let me pick some questions from here. What question you want me to do from number 1? H is good. Okay, so I'm gonna go ahead and go here. Copy image. So I'm over here. You guys should get inspired to use a Microsoft Surface for your schoolwork. Imagine I get like an advertisement like deal because I do this over and over. That'd be amazing. All right, so that's H, right? So this is problem number 1H. Okay, I'm gonna make it smaller though. There we go. Now let me go ahead for number 2. Which one do you want me to do? Which one do you want me to do for number 2? F it is. Let's do number F. Let's do F. Copy image. You come here. I'm going to paste it. It's going to be humongous. I'll make it smaller. I'm going to go ahead and align it. Guys, look at how cool this is. Don't you guys wish to be like me? No. All right, 3. Which one do you want me to do from 3? Which one do you want me to do from 3? G. Okay, G is good. I like G. Let me actually do 2 of them. We're gonna do a less than and a greater than, but I should do 2 of them. There's a reason why I want to do 2 of them. Let me do A and B, because I guess for this one I should actually make sure I'm giving you 2 examples from there. And I got a limited time to do it, by the way, because we're running out of time, because this is life. Oh my gosh, I can't highlight anything properly. Okay, here we go.
Yeah, because you're using a circle. Maybe if you bought Max.
Max can't do this, bro. Not yet. When they do, I will buy one. I have Max at home. I have 2 Max. It's just I can't use them very well. I can't play video games on them either. For my wife. Wait, I highlight the first one and I didn't do it. I didn't put it here. All right, so we're almost there, guys. Sorry about the delay. It's just, you know, when you have such high technology like this, you know. All right, and the last one, pick something that looks horrible for the last one that you want me to do.
Okay.
Okay, it is. All right, so my goal is to get through these questions within the allotted time and have it recorded. That's all. So let's go with 4. Paste it here. Make it smaller. Here's 4 and here's 3. And this is, I guess you go, you know, for number 1, they want you to use graphs, sketches to try and figure out the solution to this. So if you look at this here, this is a factored form. And I guess it's worthy for me to write it out like this. I mean, I don't have to, but I just want to go ahead and just write it out for you this way. And I'm not going to use it for anything except just say, this is what this is. So this comes out to negative x squared minus 2x plus 3 is less than 0. That's what that is in factored form. Now, if you were to get the zeros here, or the y-intercepts, x would equal negative 3, and x would also equal to what? 1, positive 1. Now, notice this symbol here, this sign here, it's negative 1. There's a negative 1 there. So that means that this parabola, this quadratic, is going to be facing down. I know that for sure. So if I had to make a sketch of it, at negative 3, I would put a dot. And at 1, I would put a dot. And so I know that the vertex is going to be in the middle of those 2, I think. Right? So negative 3 plus 1, that's negative 2. Negative 2 divided by 2, that's negative 1. So at negative 1, somewhere along this line here, and obviously I didn't draw things to scale, so let me make it look a little bit prettier. Not much more prettier. There's only so much you can do with an axis, but something like that. So this graph here does this. Now, when is that less than 0? Well, what values of x does that parabola show negative values? So for instance, between negative 3 and 1, do you realize that these values here are all positive? Are those greater than 0? I mean, less than 0? Are the values between negative 3 and positive 1, Are those values less than 0? Okay, so let's go through them. Here's -3. Over here, are they positives? The y's. They're all the y's, right? The y's are the values we're interested in because that's a result of inputting your x. The output is the y. So between -3 and 1, the values that are exhibiting here, the range, I guess I don't want to say range, but between here, they're positive. When are they less than 0? When it's beyond -3, for sure everything is negative. And when it's beyond 1 in the right direction. So the answer to this would be x is greater than 1 or x is less than -3. So that's how you would use a graphical method to determine the solution. Make sense? It is an or. In general, if you graph this, if basically this says this. And I should really make sure this is open circle. In this case, less than 0. Because who's taking the place of y here? Remember, the basic form of our quadratic is y equals ax squared plus b. You see it? Plus bx plus c. Now, obviously, we're going over this. I see people in class. I can figure out if you're paying attention. Some of you are paying higher levels of attention than others. Make sure to pay attention. And make sure when you go home, you practice this. Very important. Now, for number 2, they don't ask you to do a graph. They don't ask you to do a graph. What they ask you is to use critical values. Let's see the word they use. I forget. Because critical values. Use a table based on critical values to solve. I think the critical values as zeros. Because we know if I write something and it's factored this way, I can take advantage of the zero product property. And I can say, well, the answers to this are, the zeros are x equals to 2/3 and x equals to what? -5. Now, I will make my number line in rainbow color. It's very important to use rainbow color. If it writes, it doesn't want to write, bro. No. All right, let's try. Oh, it doesn't want to do a line in rainbow color because it has multiple colors. So it wants to be solid. It didn't let me. That's so sad. So there we have a number line. Now negative. Oh, wait, but part of it was rainbow. I guess it was too thin and I wasn't seeing it. So there must be a rainbow there. There's a rainbow. It just wasn't visible because the rainbow color was too thin. Let's make the rainbow color bigger. So let me go ahead and erase the diminutive rainbow. And it didn't erase, so it didn't listen to me. I gotta erase it though. What is it doing? No. No. Even worse. Now I lost everything, bro. Oh, okay. No, it's... Oh, all right. You saw that, right? I'm trying to just make a rainbow come out. It's like the universe is not cooperating. All right, here. So let's do a rainbow. Once again. Damn, it's too thin. Go back. This is not cooperating with me. I want a rainbow, bro. There we go. All right, so here we go. Rainbow. So -5 is somewhere over here. 2/3 is somewhere over here. And so this here is less than or equal to. So I can do a closed circle here. Closed circle, closed circle. Because at -5, it is 0. And at 2/3, it is 0. So those are good solutions. The question is, what else are the solutions? So what we do is we gather test points. So let's test over here. Can you pick a value over here that we could use? To the right. 1/3 is smaller than 2/3. I want something over here. How about 1? Yes. 1. So if I put 3 times 1 minus 2 times 1 plus 5, is that less than or equal to 0? So 3 times 1 is 3 minus 2 is 1 times 6. Is that less than or equal to 0? Is 6 less than or equal to 0? No. So over here, nada. Now, for the sake of it, I'm going to go ahead and test here in the middle. What number should I pick for in the middle? How about 0? I mean, you could pick -3, you could pick -4, you could pick -1, you could put -4.9999999 if you like, but I like to pick 0. I think it's easier. So 3 times 0 is 0, right? 3 times 0 minus 2 times 0 plus 5 less than or equal to 0. So that's -2 times 5 less than or equal to 0. Is -10 less than or equal to 0? Yay! So the values between -5 and 2/3 work. We also know that -5 works, and we also know 2/3 work because of less than or equal to. Yes or no? So now, what value would you pick to test on the left side of -5? -6 is a perfect one. It's right there. It's close by. Makes us feel good inside. So let's test -6. 3 times -6 minus 2 times -6 plus 5. Is that less than or equal to 0? So 3 times -6 is -18. -18 minus 2 is -20. -20 times -1 less than or equal to 0. So that's going to be 20. Is 20 less than or equal to 0? No. So over here is no good. So now this, the correct answer is everything in the middle here. So our answer will go something like this. And I'll go ahead and, should I have space for it? Of course not, but I'll write it here the best I can. X is less than or equal to 2/3 and at the same time greater than or equal to -5. That's how I would write my answer. This is an and situation. The previous one was an or situation. When it goes into the center, we say and. When it goes outward, we say or. Okay. Make sense, guys? Does this seem super difficult or is it okay? You can talk to me, guys. I'm a person too. Why are you guys communicating in this way? Do you have abilities that you just stared at her and it felt like she stared back at you and you guys were communicating? Telepathically? Wow. And it sounded mean too. Like the look was. All right. So now the third one says to use an algebraic method. An algebraic method. So we have x squared plus 3x minus 5. What's an algebraic method? It means use the quadratic formula. Again.
So isn't like x is greater than or equal to?
A equals 1, B equals 3.
So like when you do it,
What we do is okay, so the quadratic formula usually, so remember with the quadratic formula, here's standard form, right? If you set y equals to 0, ax squared plus bx plus c equals to 0. Now this is in the form that we can do for quadratic. Make sense? That's all it is. So in this case, this is the y, but we replace this, the equal with with an equality. So what we do is we temporarily pretend that we have an inequality, that we have an equal, sorry. So we can find the critical values. Because in this question here, we could find the critical values immediately. The zeros, because it was already factored. In this question here, we use the critical values to plot it and to see it visually, what it meant to solve this. Does that make sense? Are you sure? Okay. That's all that matters.
and then we just quadratic formula.
Well, in this case, yeah, you use quadratic formula. Let me zoom in a little bit. So we have x equals negative b. Don't forget the negative. B squared minus 4ac all over 2a. X equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 5 divided by 2 times 1. X equals negative 3 plus or minus 9 plus 20. Be careful with your signs. Some of you, when you're taking the test, you weren't careful with your signs. Some of you couldn't multiply things correctly. Like you forgot your timetables, you use your calculator wrong. And so now we have x equals negative 3 plus or minus the square root of 29 divided by 2. And now we get our calculator out. And obviously, if I told you negative 3 plus the square root of 29 over 2, you'd be like, I don't know what you're talking about. Because we got to test some values out. So it's 3 negative plus 29 square root equals, and divide that by 2. And so I'm going to go ahead and use 1.2. I mean, that's not a good value, but x is either approximately 1. I really should write 1.19. I feel better with that, but I'm going to use a test point of 1.2, okay? And so 3 negative minus 29 square root equals, and divide that by 2. And so x is also approximately negative 4.19. So we got that. Just by executing negative 3 minus the square root of 29 divided by 2. Just do it on your calculator. Make sure you get the same. Right. So now you got your 2 test points, your 2 critical values. You make your little number line. Here is a 1.2 and here is negative 4.2. We go up, we look at it for a second. It's greater than, so that means these guys are open circle, right? In other words, this here is negative 3 plus the square root of 29 divided by 2. And this here is negative 3 minus the square root of 29 divided by 2. Okay. Okay, Brian, you may go, but like, please study this. All right. So now we got to decide. All right. It has to be what? Greater than 0, right? So let me pick some values. What value can I pick in the middle? What value can I pick over here? What value can I pick over here? -5. So let's go through them quickly. So we're going to pick 0 squared plus 3x, 3 times 0, -5. Is that greater than 0? Is -5 greater than 0? Is -5 greater? All right. -5 greater than 0. No. So now you know that here in the middle is no good. I think if you did that math right, now you know that the only two answers that are going to make it are the other sides. So, well, I think
It's never gonna work for only one side, right?
I'm not sure. Sometimes there are exceptions. That's why you always do the problem. Yes.
You mean to like an odd, to the odd thing? Yeah.
If it's an odd function, then it's not quadratic.
The thing that like it touches the line, it gets close to the line. Not the asymptote. No.
It was like something that like it could be, it didn't work on the right in the middle, but it worked on the left.
Okay. Yeah, I know what you're talking about. Not in this and here. I would have to add more things to it. But don't worry. We'll do. Don't worry. We'll cover all things. All right. So is this greater than 0? Obviously, you could tell that 4 plus 6 minus 5 is greater than 0. So it works over here on this side. And it's probably going to work on the other side too. So let's say -5. -5 squared is 25, not -25. Be careful. Those mistakes are rookie mistakes we should not be making. And you can tell that this is going to work too. So therefore, x must be greater than -3 plus the square root of 29 divided by 2. Or you shouldn't. But if you did it on the test and I clearly see what you mean, then I would be honest. On the AICE test, they would also see it, but doesn't this make you feel smarter? Look at that. Look how the board writes magically. I can write to you while walking in the halls.
A lot of lag.
Do you think it's going to be laggy?
Yeah, it's laggy now.
Yeah, but like, okay.
Don't tell me you're gonna start teaching while you're taking shit.
No. Let me see audio. Click to join audio. Test speakers and mic. No, let me not do that because we're gonna get feedback. Let's do it for another day. I gotta finish this because this is needed for the other class too. Well, you know, the other kids, are they important? Yeah, they are. All right. So let me see, because I'm running out of time, of course, because this is my life. Drag this over. Well, you guys should be in awe of the Microsoft Surface.
This year, if you get that sponsorship, you won't have to worry about time.
That's true. You can make out some decent money, but I really do like this product. I just wish I had a better battery life, honestly. But I think they're going to get it with the Raptor Lake CPUs. I think they're going to be able to get it. This one doesn't want to do it, so I'll try. By the way, I'm going to be building for the 3-year-old her first computer. It's going to be an i9-9900K with an RTX 2070, and it's going to be small form factor. So her computer literally is going to be.
For what reason?
So she can learn how to use computers early on. No, so she can eventually play World of Warcraft with me. And so I can have a full team.
You don't need that much with World of Warcraft.
Yes, but why would I give her anything less? Don't you feel sad?
It'd be cheaper.
No, those are leftover parts from other computers. All right, let's do this one. Now, look, I want you to notice that this came out to, this here is greater than, ended up with an or. Now, I don't like this rule, but greater than, when written left to right, and the x squared is positive, you will have an or. Now, as long as x squared written left to right is positive, less than, usually is and. I hate doing these rules, but it's an and. So this will be an inward, right? And over here will be outward. Okay, so now let's do 3B, and then I'll solve the last one, and I can end up this video and put it on YouTube and put everything, and then give you some practice problems, and you can do the practice problems. We can review it next class and test for next week, because we're going to start doing derivatives, and then you're going to start feeling smarter. There's coffee here on this desk.
If it's less than or equal to, that's and.
Less than and.
Less than.
Greater than or. Greater or. Less than and. Got it? All right, so let's do this one. Quickly, I'll do it because I'm just running. This one's not good though. All right, let's do it. A equals 1, B equals 6, C equals 9, -6 plus or minus the square root of 6 squared minus 4 times 1 times 9 divided by 2 times 1, -6 plus or minus the square root of 36 minus 36 divided by 2. So -6 plus or minus 0, square root of 0 over 2. Or maybe it's -6 plus or minus 0 divided by 2. So maybe it's -6 plus 0 divided by 2. Or maybe -6 minus 0 divided by 2. And that's going to be -3. Or -3. Oh my gosh, they're both the same answers. There's -3. Come on, computer. Yes. And it writes it slower than I'm writing. It feels like it's in slow motion because I'm writing faster than that. It doesn't matter. So here's the answer to this is it's a repeated root because the discriminant was 0. So we have one solution, which we can say it's a repeated root. That's what it means to be a repeated root. So if you were to graph this, it would probably look something like that. Actually, it's going to be on the other side. Let me go ahead and just put it on the other side. It's going to be actually over here at -3. It just touches -3 and goes on forever. Now, here's our problem, and you're going to see the problem quickly. What is our test point? What is our critical value? What is our critical value? -3 is our critical value. Less than, open circle. Pick a number over here that can pick on the right to test. It's 0. -2 works. It's just easier for me because I can just go straight up here and I go 0 plus 0 plus 9. Is 9 less than 0? No, doesn't work over here. Okay, so it has to work on the other side. So pick one on the left of -3. -4. I'm going to do -5. So -5 squared is 25. 25 minus 30. So is -5 and -5 plus 9. And is 4 less than 0? No. Is 4 less than 0? No. So here, it doesn't work anywhere. Why? Because look at how the graph would have looked. Look how the graph would have looked. It's always positive. It's never less than 0. So there's no solution that would satisfy that inequality. So do you see how less than and didn't work in this case? There was nothing. That's why you need to go full. Does that make sense? Very important. No solution. And the reason there's no solution is because nothing works. Even -3 doesn't work. Because with -3, it's 0. Is 0 less than 0? No. But if it were, if this, all I needed to do to have a solution here of some sort is I would have to put the equal there. Less than or equal to 0. Then, oh, of course, -3 works. But then we just have one solution. Make sense? It's important to see this in as many ways as possible. And the last one, the one that nobody wants to do, but if I were to do this one, which method would you instinctively try and do? Would you try to graph this? Would you try to do factoring? Would you just use this the quadratic formula? What would you use if you were doing this to find your critical values and to proceed and do the problem? I would use quadratic too. I would default straight to quadratic. I have 21% batteries.
Yeah, the Mac can have 6.
A equals to 12, B equals to 5, C equals to -3. -5 plus or minus the square root of 5 squared minus 4 times 1 times 12 times -3, all divided by 2 times 12. -5 plus or minus 25 plus, because negative times, so you're gonna have negative times positive is negative, and negative times negative is a positive. So you know it's gonna end up plus. So let's do the multiplication here. 12 times 3 negative is -36 times 4 negative is 144. 144. And then we have 24. 144 plus 25 is 169. 169, we have a positive discriminant, so therefore we're going to have two solutions. So you have -5 plus 13 divided by 24, or you have -5 minus 13 divided by 24. And so you have 8 divided by 24, or you have -18 divided by 24. And 8 divided by 24 is 1/3. And -18 divided by 24 is negative what? Well, 3 goes into 18 6 times, but there's a higher common, whatever it is called, common denominator or common whatever factor.
3 over 4.
3 over 4 should be your answer because 6 works. And so those are your two answers to this question. But are we done? The answer is no, because we have to test the critical values. And this is not writing as quickly because I think it's running out of battery and it's overheating. It's always like that. I sent a picture that Sophia did of me. My wife is like, no te respetan. Well, I got angry. I'll show you the picture. It's a good picture. Everybody looks awesome. So 0, we have 1, and we have -1. So let's test. 12 times 0 is 0 plus 0 is 0, right? And then we have -3. Okay, 12 times 0 is 0 plus 0, 0 minus 3 is -3 greater than 0? No. Now, greater needs to end up being an OR. Greater, if the x squared is positive, written from left to right, we're good. So we're going to end up with an OR. 12 times 1 is 12 plus 5. That's 17. 17 minus 3, that's 14. Is 14 greater than 0? Yes. So this is good. Yay. I'm going to make a good check mark, though. That's not a very good check mark. Check mark. All right. -1 squared is 1 times 12 is 12 minus 5. That's 7. And 7 minus 3 is 4. Is 4 greater than 0? Yes. So over here, it's good. So we say x is greater than 1/3 or x is less than 3/4. Obviously, it's an open circle here, and you make arrows in that direction, and we're done. And you should feel a little bit smarter now because this is done. Yes, I'm listening. Fedor. All right, guys, let me show you the picture. And my wife is like, no, all right. But I have to hurry because and stop share and end this and end meeting.